Well, thank you very much for inviting me to give you this presentation. I really enjoy talking about WWVH, and I'm proud of what we're doing. The attraction of the job for me about eight months ago, or a year actually, is when I heard about it and started applying. It took a long time to be hired in the federal government system. And anyways, it was sort of what I viewed as a dream job. I had used WWV services and by extension WWVH for so many years, and I was really intrigued. Hopefully, I can share some of that with you today. So I'll just echo a little bit of what how I would introduce myself. I've been a broadcast engineering manager at radio stations, AM and FM stations, for many, many years. And most recently, before this job, I worked with iHeartMedia as an internal consultant. They're the largest group. And so what I was doing there was helping engineers at their facilities with trouble, difficult, thorny problems and things like that. So, but it was a full-time position just to be sort of standing by to help the field engineers. They had recently laid off a lot of field engineers, so the guys were under a lot of pressure. So that's the job I most recently left. I did work for many years here or there in Wisconsin as the director of engineering for Wisconsin Public Radio, which is a regional radio group. Had about 30, well, by the time I was done, I think we had 34 stations. So I do hold a number of FCC licenses. The most interesting one is the radio telegraph ticket, which is literally number one. So that was just by the accident when I got interested, and when the FCC decided to reorganize their radio telegraph tickets. They no longer have the first, second, third, or first and second, anyways, structure that they had. They now have just one ticket, and I have number one. They're looking for expecting a lot of people to get that ticket. Look at all those zeros there. So the NIST radio station, that's the National Institute of Standards and Technology, used to be known as the National Bureau of Standards. The radio station WWVH is located on the island of Kauai, which is sort of the northwest most significant island in the Hawaiian group. And it's mostly a rural island, very rugged terrain, limited roads, but there is a lot of tourism, so that sort of offsets that. So there is development, but it isn't always development for locals. It's focused more on the tourist traffic. It's known as the Garden Island. It's you've probably seen it in a lot of movies whenever they need to show kind of a lush place, a jungle or something like that. They can get aerial photos here that really much easier than a lot of real rough terrain places, and achieve that. For example, the opening of Jurassic Park, the movie Jurassic Park, which involves helicopters flying to this theoretically remote island and seeing giant waterfalls and beautiful mountains and rugged terrain, that was filmed here. The radio station is located on the southwest corner of this island, and it's on a Navy base, which complicates a lot of things that I would like to do. They feel they're in charge, they're the landlord, and so they are to a great extent. It's known as the Pacific Missile Range Facility, and modern missile systems are all tested and developed with this facility, at least a significant part of the operation. The latest thing I think was the ground-based, land-based Aegis missile system. There's actually, I think it's an active site meant to defend against missiles, but it is also the test facility just down the street from the radio station. So we're well protected. A little bit of background. National Institute of Standards and Technology has been around a long time, and it's a physical science laboratory and provides both research and development of things to help American industry and science to be competitive. The services we provide are time and frequency standards, and we're part of the time and frequency division of NIST. They also provide the national NTP service, for example, the computer network time source. NIST.ntp.gov is one of your best choices for your computer time syncing, for example. And I list the mission and vision of the organizations, and that we have facilities in Gaithersburg, Maryland, Boulder, Colorado, and Fort Collins, Colorado, where my sister radio stations are located, which most people probably hear WWV more than WWVH. VH is meant to serve the Pacific and Alaska. Originating the operation here in 1948, it was on the island of Maui, not Kauai, in what was then the U.S. territory of Hawaii. And I have a photo there of that facility. It operated at much lower power. I haven't been able to pin down the actual numbers on the power level. Everyone just describes it as low in all the materials I've seen. And I suspect, based on photographs I've seen of the old facility, that was a moving target, what power level they were able to achieve with the parts and equipment available. And that was one reason maybe they wanted to move to a place that had a little bit better infrastructure, power, AC power capability, and so on. The big deal, it probably was the deciding point, was that the original station site was threatened by the eroding seashore. And the period of the station's operation, 75 feet of beach and shoreline had eroded away, and the water was lapping at the base of the building and the nearest antenna. So they determined that it needed to be moved. Now, for this audience, I'm sure I don't need to point this out, but it's a shortwave station and operates on several frequencies, 2.5, 5, 10, and 15 megahertz, with either 10,000 watts or 5,000 watts. What we transmit is described here by this period of 60 minutes. So this represents 1 hour on the clock. In the broadcasting world, that would be known as a format clock, but we call it the wheel, which actually is more of a reference, I think, to like coast stations, radio telegraph coast stations, and they would transmit the list of call signs that had stations that had traffic. The ships that had traffic waiting for them would be called the wheel. And it came from the concept that it was actually a mechanical device turning and keying the CW as programmed. And when you've heard, remember when you could hear VVV, this is KPH or whoever on the shortwave bands, that came from a wheel. Nobody had to sit there and send that man. So we operate 24 hours a day, 7 days a week, and I do my darndest to keep us up all the time. Broadcasts include time announcements, and of course we're on standard frequencies held to close precision. Any corrections to universal time are transmitted, and there's a BCD time code, a low frequency encoded signal that has a little bit of data there about the time and other factors. And the special receivers can decode that, but there aren't too many of those around anymore. Most of that is focused on WWVB, which is the very low frequency 60 kilohertz signal out of Colorado. But the similar concept would apply to either WWV or WWVH. It's just that there aren't very many that I've identified commercial products available for that. Also, we transmit geophysical alerts, that is to say, sort of solar activity and its impact on radio propagation is transmitted every hour. That's very useful for me. I hear it by accident, and I don't even realize I'm hearing it, just in the background. And then I realize, well, yeah, we're having a radio blackout right now, so I'm aware of it. That's handy. when I go home and try to get on the air. That's happened a lot lately. Also, we're currently running a special experiment in one of the reserved minutes with a group that's called HAMSci, and it's a group of amateur and professional scientists using ham radio and other what I would consider hobby radio capabilities to do real science. And we transmit a signal every hour that is very interesting, complex waveforms, frequency sweeps, noise bursts, and it's all intended for SDR receivers that are distributed around the globe to receive and record the data about the characteristics of the signal. And then scientific research is done on that data. So that's pretty cool. Now, most of you have heard WWVH. At some point, you might realize that it has a female voice instead of the male voice that you hear on WWV. And WWVH announcements have been since probably the old facility. I don't know how far back she goes, but her name is Jane Barbie. She's passed away now, but she was one of the most famous of the telephone company recording voice artists. And I gave this presentation to a group of younger people, and they said, "What do you mean telephone company recording artists?" And I said, "Well, we used to get recordings that weren't synthesized voices. They were real people's voices that told you if you had dialed the wrong number and so on." And Jane Barbie was one of the leading ones of those. I'm sure you guys probably remember also the time and temperature services that a lot of companies and telephone companies offered. And she voiced hundreds of those, probably more than that. That's a picture that I found. It's in a frame with glass, so you're actually seeing a reflection of the rack room. And her picture is posted right there and has been probably since the station was built. Now, originally, her voice came from this interesting device called the Audicron. And the Audicron was a mechanical audio playback device and had a rotating drum. You can see it in the photo there, with a head that can be moved to different tracks on a magnetic media. And so the controller for the station, or in the case of a time and temperature system at a bank or a local telephone company, there would have some form of clock that could trigger what hour it is and what minute it is. And there were tracks on there recorded in our case, in Jane's voice, to play back, how many minutes and which hour we're in, put it that way. And there were probably machines that had more drums, so they could say more different categories of things, like temperature, for just the easiest example. In this case, the left part of the drum is the hour announcements, and the right part is the minutes. That device is gone, though, because it was leased. They never sold them. They only leased them from that company. And so that would have been an ongoing cost just to have that. Also, any other announcements, and we did other kinds of announcements. There used to be Mars activation notices, and I don't know. The geophysical alerts go back into that point, and they were manually recorded by someone. I think there was also a time when weather forecasts were present. They were played from what I call cart machines, which were endless loop tape cartridges that we used in radio and television for many, many years. So those machines right there are very familiar to me from when I would take over an old radio station. That brand would often be there. That's an ATC, automatic tape company. Now we play back the material from digital data files that are stored in either the timecode generators or a PC. Here's a view of the shielded rack room. We have two shielded rooms. One is more of a workshop, so we can have a bench and test equipment in an area that's relatively free of RF from our many transmitters and antennas all around us. And here's the room with the atomic clocks and timecode generators and so on in these racks. And the signal generators, you might say, the function generators that originate each frequency's basic RF signal. Here's a little view of the front panel of one of the atomic clocks. They're reasonably modern. They are cesium-based, have a tube inside with a cesium sample, and a beam of cesium atoms is created. And the general concept of these atomic clocks is that the beam is energized. And I haven't been able to confirm in these clocks if it is by an RF source, but it probably is. And in some clocks, and maser clocks would be the same way. You're exciting these atoms so that their outer electrons move up to the next energy level. Because the interesting physical characteristic is when they decay back to their normal level of excitement, they emit a photon of a very precise frequency, a predictable frequency. And that is ultimately your source, your standard source from an atomic clock. Now, these clocks will run on their own very well for long periods, but they do have the ability to be steered, that is corrected, because there is a drift. There's always a drift. This is a phase lock loop system, and there's room for drift. So, but the drift is on the scale of, fractions of nanoseconds. But at NIST, that matters. So we have a system to remotely steer from Colorado, where in Colorado is where the national, what is known as the time scale, is positioned. And it's many more clocks. We have 4, actually, 3 in normal service, 1 as part of that link. And it is not a trivial problem to remotely send really accurate time. So we have an interesting system that uses common view of GPS satellites. And then because, we're using only satellites that both facilities can see, in other words, the satellites that are above the horizon for both Colorado and Hawaii, and that's not that many at any given moment, we then can subtract out all the problems with GPS and get a reasonably good time. So keep us within a nanosecond. But as I say, these clocks will do that on their own, even if that link went away for quite a while. Our signals are pretty ordinary double sideband amplitude modulation, what you would think of as standard AM, which is transmitted by most broadcast stations on the standard broadcast band. Getting into a little bit more creative stuff these days for power saving and things, but most stations still run very, very normal AM. Same with shortwave broadcasters. They're experimenting with a lot of different techniques, but most of them are still running normal AM. The modulation levels are 50% for any of the steady tones that we transmit, 50% for the BCD time code, which is down at 100 hertz, 100% for the ticks, the second pulses, as well as the minute and hour tones. The top of the minute tone is 1500 hertz instead of the 1000 that WWV uses, so that's another way to distinguish the two stations. And voice announcements usually end up around 75%, although they can vary somewhat. The audio processing in use is not sophisticated like I would use on a broadcast station. So some of the variations we get from other, like geophysical alert announcements and the ham-sci announcements and stuff can vary a little bit. That's not critical. Here's an oscilloscope that's looking directly at the RF sample from one of the transmitters on the top view, and then the audio being applied is on the bottom trace. You can see, although I will admit, if you're really savvy, you'll notice that the audio is out of phase. I didn't have any in-phase audio available at that rack, so I let it go. But anyways, you can see that the audio is then modulating there with right at the moment of the top of the minute tone. Pretty close to 100, not quite. Better that it not be more than 100, negative anyways. Here's the steady tones, what you might think of as sort of the beat, the bong, bong, bong. That's it's the steady tone getting interrupted by the ticks. Same principle. And here you can see the low frequency BCD time code at 100 hertz mixing with the steady tone. So you can see the low frequency is modulating the signal as well as the normal audio. Now, I hired a special model here to show off the transmitter room. So that's me standing in front of one of the original transmitters for this facility. It's on 2.5 megahertz, 2.5, but every frequency has a main and a backup. And the backup can take over automatically from a cold start. So works very nicely. That's one aspect I haven't felt any urge to change. In this view, you can see that original AEL transmitter down on the end. The site was originally built with all AEL transmitters, and I'll show you a close-up of it in a minute. But in the main view here is transmitters for 15 and 10 megahertz, the main transmitters, and they're from a company called Elcom Bauer. And I remember Bauer as the makers of a very nice 1 kilowatt AM broadcast transmitter that was available in kit form. So the broadcast engineer or engineers at a station could buy this kit and assemble their transmitter and save their company money that way. But they were very nice transmitters. I do believe they used an unusual set of tubes, though, that became hard to deal with. And I'm drawing a blank now on what the designation of that tube was. Was it like a 5CX 5000 or 1000 maybe? I don't really remember. But these transmitters, I'm drifting off topic as I sometimes do. They have a solid state driver, which is pretty cool, although they blow up regularly. And the modulators are 4CX 5000s, and the power amplifier tube that is being modulated is a 4CX 15000. Here's a view with one of the doors open on those transmitters. So the doors are kind of just to keep the controls and stuff out of sight and out of reach of the casual passerby. High-tech painter's tape being used to mark the tuning adjustments. Here's a view of the transmitter I was describing that's the oldest, 1970s vintage. The Elcom Bauers would have been 1980s technology. Purchased probably around 90, I think. The AELs, though, there were 6 of them, I think, at the site originally, and they're only remaining are 2 on 2.5 megahertz, and they're extensively modified. So 2 things tell me that there were trouble with the AELs. Is number one, they wasn't very many years till they bought more transmitters and took most of them out. And then there was the issue of them being extensively modified, and they're so different as to not even be, they're using a different PA tube, different modulators, so on. Oh, I'm sorry, this is a linear amp, so never mind, no modulator. Here's a view from the original proposal for the purchase of the new transmitters for the facility. The console is still in operation, the desk with the racks in it, although there's a lot of different gear in it now. And it looks like that because it's messy and has a lot of stuff stacked up on it. I was working in that rack just yesterday. There's a device there that monitors this RF sample from each of that one was from a whip on the roof that monitors the actual signal after the antennas. And it was not reliably reporting the state of affairs, so I was fixing that. We also have some Rockwell Collins ex-military transmitters. In the recent decades of operation, money has been very tight for our radio stations, and so we were, I'm sure, eager to receive help as transmitters became ever more unreliable over the years and more difficult to work on, that we get something a little more modern. These are 10 kilowatt linear amps with an exciter to drive them, so they can be a standalone transmitter. And they have 3 driver tubes. That is a low-level driver, an IPA, intermediate power amp, a pair of 4CX 350s, and the PA tube is a 4CX 15000. There's a little better view of just one of them. They're multi-mode as a linear amplifier. They're auto-tune, anywhere between 2 to 30 megahertz. That's way more complication than we need, and is often part of the problem we have with them. You know, it's auto tune can get confused when you have other signals, big signals nearby, and so anyways, that it would almost be better for our purposes if they were not auto tuned. But I do like having the capability to go anywhere from 2 to 30. That's very handy if we need to rearrange things in an emergency. And it's important that they be able to be driven externally. Here's a close-up on the exciter. It adds local control capability, which is important, sort of your human interface with the rig. But the coolest thing I enjoy is that it's a 10 kilowatt transmitter with a headphone jack, a microphone jack, and a CW key jack right on the front. Thank you, Collins. That's fun. I'll zoom in on that. You can see now the headphones would be fed from a receiver in usually another site, and that wouldn't apply with what we're doing. But you could plug a mic in and just talk on the air, or you could key the carrier with the Morse key. I haven't done it yet. I've been able to resist the temptation. Here's a lineup of the tubes that we use in the facility. We're right now in the process of purchasing a new transmitter for 5 megahertz main, and it will be solid state. But here's some of the funny things about that transmitter. I probably shouldn't say the maker because of federal rules of purchasing and stuff, but it's being adapted from an over-the-horizon radar transmitter that's produced, because it needs 40 kilowatts peak envelope capability output. And it is twice as big as our existing tube transmitters. And that kind of blew my mind, because even broadcast transmitters I normally encounter, I've been buying solid state rigs now for 15 or 20 years for AM and FM stations, they're usually smaller. So there's a lot of power supply and a lot of RF modules all working together to create that signal. And here's the best part. Even though it's twice as big, it's water cooled and has to have a heat exchanger out back, outdoors. It boggles the mind. But I think it has a chance of being extremely rugged, so I'm not arguing. Here's our dummy load. It can handle 25 kilowatts. It's about 6 feet tall. And it absorbs 25,000 watts at 50 ohms with a nice meter on the front to give you a real easy display of the energy you're putting into it. And in our case, it's handy that it can roll around and be moved to work with different transmitters. Normally, our transmitters are each dedicated to an antenna. So, so you could turn both 10 megahertz transmitters on at the same time. And they're far enough apart, the antennas are far enough apart that you would get an interference pattern forming an inadvertent directional antenna. But for a moment, that wouldn't be a big deal. So we don't have to often use the dummy. And it's really when something serious has gone wrong and we need to run the off-the-air rig more than would otherwise be the case. It's just made up of a bunch of what some people would call glow bar resistors, big cylindrical resistors. I should have opened the door and took a picture. Here's an aerial photo of our aerials looking down on the site. So you can see there's 2 antennas for each frequency. The 15 megahertz standby antenna is actually a homebrew antenna, but otherwise they're all commercial products. A very typical example here is this vertical radiator. It's got a bunch of ground radial wires. So most are all quarter wavelengths, but there are on 5 megahertz, they're half waves. These antennas are fiberglass, epoxy fiberglass composite with sort of a multiple helix inside of copper strips going up. The half wave ones are guide. I think all the rest are freestanding, if my memory is serving correctly. Here's a look at the base of one of the fixed frequency antennas. The mast is the antenna, and then you can see the ground system radiating out under it. An interesting point is that it's sitting on a metal plate with a big hinge, and when you would need to work on it, or they'll need painted not too far in the future to protect the fiberglass, you can just tilt them over. I say just. That's a big project. This is an adjustable. We have two adjustable antennas, and right now we dedicate them to one particular frequency each, but they can be shifted to other frequencies. Here's a view of the 5 megahertz main, which is a 2-element directional, and it's favoring west to serve the Pacific, but it's not that much of a directional. It's still spraying signal all around. View of the base of one of those 5 megahertz antennas. The skirts that you see are meant to keep water off the base. I was reading an old memo about they were running when they initially started using these antennas. They were getting a lot of corrosion, weird corrosion on the mounting bolts and stuff, and it seemed to be RF-induced forms of corrosion, and just keeping the direct rain off of it made all the difference. The antenna field, the whole property for that matter, is protected by armed guards. These are what are known as the Niihau, the geese in Hawaii, and they're probably descended, it seems very likely, descended from Canada gooses that got off track in their migration and ended up in Hawaii. These birds, much like Canada geese, have pretty much two modes. Either they're interested in what you're doing and sort of want to get involved, or they're upset and angry about something and honking and chasing. I've talked to them. I've tried to negotiate, but I'm not making much progress. Either they want to bite you or they want to slap you with their wings. When they get that energetic, I understand they have chicks somewhere. They have a nest somewhere around. The whole facility, and the antennas particularly, are immediately adjacent to the beach. Not where I would put any radio station if I had my druthers. High winds, saltwater spray, grit, it's kind of a pain. And makes everything, and including inside the building, corrode so fast as to be astonishing. So there's an island on the horizon there you can see in the distance, Niihau it's called. And it is a private island owned by one family, and they've owned it since, I think, the 1600s. They bought it from the Hawaiian king who originally, I think, unified the Hawaiian Islands, and he sold it for money. So it's one family, but there are natives that live there. Not too many anymore, but there's an interesting World War II incident that occurred there. I'll just quickly explain because you guys are probably interested in history. One of the Japanese fighter pilots had suffered one bullet through a fuel tank and during the Pearl Harbor attack in 1941. And their procedure, which I had never heard about till I was researching this incident, was anybody who was damaged in the attack forces were to go over to Niihau Island, and a Japanese submarine was positioned there to rescue flyers. So this fellow, he flew over to Niihau, but also he flew around a long time. I think he might have been a little lost. He didn't know what to do. He probably had enough fuel to get back to the carrier, but without being with the bombers, he didn't know how to get back to the carrier, unless he was an extra special fighter pilot. Their procedure was that the navigators and the bombers handled that. Anyways, he crash landed on the island. He did not land on the beach as was intended. He didn't see the submarine anywhere. It turns out later the submarine didn't stay long enough because he flew around a long time, sort of sightseeing the island. Anyways, he landed there, and there was a couple there of Japanese descent who sort of helped him to take over the island or try to take over the island for Japan. It's a story I hadn't really heard before and was in a situation where actually it's a fascinating story. And in the end, the pilot was killed after he shot one of the locals who was of one of the big guys of Polynesian descent, like people from Samoa. Sometimes the guys are really strong and big. And he just after being shot 3 times, he picked up the Japanese pilot and smashed his head into a rock and put an end to the insurrection. Interesting. There's 2 books I know of written on this subject. And I got to stop telling stories. We still, of course, receive reception reports, the traditional letter or email saying they've heard the station, and we respond with a QSL card and a brochure. When I was applying for the job, I happened to hear WWVH when I was calibrating one of my service monitors in Wisconsin, so I sent a reception report and got a QSL card back. And when I arrived, I said, "Did you notice it was me?" And they said, "Oh, yes, we were very concerned why you were testing us." I just thought it would be fun. No testing involved. But it is a beautiful QSL. So we get a lot of questions about how accurate is the time. And it is very accurate. It would probably be the most accurate source here in Hawaii, definitely. And but there's propagation time to be considered, and ionospheric propagation particularly does vary in its speed. So there are issues when you're receiving the signal at a remote location. Likewise, we have a telephone service, and you can call us. There's the number. Call us right now. No operator is standing by. It'll answer automatically, and you can hear WWVH. The problem with calling on the phone these days is so much of our telephone network is voice over IP, which has very lax timing standards. If you were using a real landline phone that was copper wire all the way to the local central office, and that office used real switching, not packet switched audio, you would have a pretty good, well, be within 30 milliseconds anywhere you'd call from in the US. But most companies don't operate that way. So even if you have a landline phone, it turns into voice over IP, maybe just down the block, but definitely in the central office. And so you can expect a much wider variation in timing. So, but for most people's purposes, that's very good. So if you need a way to call for the time, traditional, telephone time service, there's your number. Get my numbers up. I need more callers. And long distance isn't usually a factor these days. So that's my presentation on WWVH.